relaxation time. This is something that happens with chemicals or thermodynamic equilibrium, laser beams, many different things where the cryogenic effects just change some of the relaxations, but they don't change everything. Diamagnetic things don't change when they're very cold, and the gravity doesn't change when it's cold. And then we're going to take a look in detail at how Planck's constant is affected by gravity. The relaxation has many different names in physics. Some people say it's the evolution of states. Say in nuclear magnetic resonance, they'll put different frequencies in there, and then they pause for the evolution to occur on some of these states. And this can involve gravity replenishing the internal momentum of every pair of protons and electrons. And some of the names of this is to restore thermodynamic equilibrium or chemical exchange, in which they can't explain what things are going on in chemistry, so there's this new term they've put for chemical exchange. And I propose that actually gravity is involved with restoring things at a slow rate. Then there's these things called nanokelvin refrigerators, and they only work for a few seconds, and then they get warmer again. And it's not just that they're leaking things. That I believe that the limit on absolute zero is where gravity is sending out energy. In the theory here, a length insertion occurs, and this can cause heating. For example, if mechanical motion occurs, that will compress distances in the atom, and it goes into the center of the proton and is reflected in the electromagnetic flows. And a wave function is about a velocity, and a photon can insert a velocity into this. And here's some of the math. The flux is really what a wave function is made out of. It's a length times a velocity. And that's mathematically the same as an area per second or a charge per second. It's a current. It can be a magnetic flux or a flux of current, a charge current. So that now the electron is using 2 dimensions of space, and it adds them together, and it makes a 3rd dimension that flows backwards to the proton. Now the energy is made up in an atom of a velocity multiplied by a momentum. The photon has a velocity-like property, and the proton has momentum in it from gravity, and the change in the atom's energy when a photon comes in is not just from the photon, it's the combination of P times V, momentum times velocity. The proton's momentum multiplied by the photon's velocity. The photon itself doesn't have the whole energy change for the atom. And here's the equation for H bar, or H rather. Planck's constant. It's the momentum of free space, V over tau, times a length, the Bohr radius, half an angstrom, times these universal constants, Km, Coulomb's constant, times the proton mass, divided by GQ, Newton's constant, and the charge of the proton. Now this is a place I could have a good example where this power of gravity comes into play with Planck's constant. We can take h bar multiplied by z and divide that by tau squared, and this gives a certain number of watts for an element with a number of protons z. For example, an erbium laser amplifier would have a photon energy of 0.087 electron volts, infrared. And an amplifier in a fiber optics assembly would have the erbium in it, which has the atomic number of 68 protons. And the lifetime is calculated by energy divided by power. So here's the formula, and it's E times tau squared over ZH bar. And the lifetime turns out to be 4.7 milliseconds, which exactly is appropriate for the experiments. Also, now, in the background radiation in the sky, there's this cosmic microwave background radiation, and it's pretty weak, very cool, like 3 degrees Kelvin type of cool. But now if we look at this other energy, h bar over tau, the gravitational constant at 5 nanoseconds, the energy of that photon then would be about 10 to the minus 7th eV. That's 5,000 times weaker than those photons from the CMBR. And I believe this energy, 10 to the minus 7th electron volts, is the minimum energy that a photon can have when it emitted from a single ion. So you can only get lower energies like radio waves or something by using many electrons together. So in conclusion, I just wanted to mention that the replenishment for relaxation is a contraflow process. There's 8 dimensions, as I've shown you in other videos. Actually, I could show you right here. I have this little picture that I have on the side here. Let's see, let me bring that up. And we see that here's the 8 dimensions. Proton there in red in the middle there. An electron off to the right a little bit from there. So we see there's 3 dimensions going into the proton, X, Y, and Z. And time is coming out in all directions at the speed of light. But now that hits a mirror. All these 4 dimensions hits a mirror in the center of the proton and reflects outwards 4 more dimensions. 2 of them are space-like. They go to the electron. One of them is time-like. It comes back from the electron to the proton. And the 4th dimension, it goes to the neutron over here. So let's go back to the conclusion page over here for just mentioning that photons are fragments of wave functions, and they unbalance atoms when they're emitted or absorbed. And then it takes time for relaxation and the rebalancing of the 3 electron dimensions. It just doesn't happen instantly because the momentum of gravity is quite limited. Thank you very much. Goodbye.